In this question, a research group conducts a study and found that 11.6% of articles shared through social media contain no factual content. Suppose we randomly select 7 articles based on the social media. Let X represent the number of these articles that contain no factual content. In this question now for part A, we must show that X is a binomial random variable. There are 4 rules for binomial random variables. First, for a binomial random variable, the question we are asking must be a yes or no question. The question we are asking here is it one of those articles that contains no factual content? This can be asked as a yes or no question. So that fits this description. Second, we must also have a fixed sample size. Here we're told directly that we have exactly 7 articles. We can't add any more to that. We're going to say just 7 articles, no more, no less. Now we must also have a fixed percentage. And we're also given a percentage. 11.6% of the articles will have no factual content. The fourth rule is that the outcome of each test cannot affect other tests. So whether an article is factual or not will not affect the other articles. And this makes sense because just because one article on social media is non-factual doesn't change how the others will be. One test will not affect the others. Now for part B, we are asked to construct a probability distribution for X. To do this, we'll make a list of X values. We'll begin in column A by typing the label X. Since our sample size is 7 articles, we will begin by typing in 0, 1, 2, 3, 4, 5, 6, and 7. These are how many articles that it's possible could be non-factual. When we do our study, it's possible we could get 0 articles that are non-factual, but we could have as many as 7 or anything in between. Now, we need to calculate the probability. In calculating the probability, we'll construct our probability distribution. The formula we'll use to calculate probability is called Binom-Dist. When we do our Binom-Dist formula, we'll begin by opening parentheses, and for our first entry in the formula, we'll click on our X value. After that, we'll enter the number of trials, or our number of samples. We'll label that as N. After that, we'll enter our probability, and then enter false if we're just trying to construct the distribution. If we wanted to make a cumulative total of the probabilities, then we would have entered true in the last slot. But here, to just construct the distribution, we'll say false. So in the formula, first we'll say equals binom.dist, and now rather than entering the letter X, we will click on the box where X is located. This is because X is a variable and will have multiple entries. Then we'll place a comma, and then we'll place the N. The N was 7 samples, and so we enter the number 7. Our probability of having a non-factual article was 11.6%, so we'll say 11.6 and put a percentage sign at the end. Then a comma, and the word false. When we press enter, this will find the probability of having no articles that are non-factual. Now then we can move the mouse and get the black cross and find the probability of each of these outcomes. So the probability of having one non-factual article out of the 7 is about 38-39%. 2 articles, about 15%. 3 articles, 3%. 4 articles would be less than 1%. And then we get these numbers here for 6 and 7 that end with E-5 and E-7. This is a form of scientific notation. If you do see E and then a negative number, just think of them as very small decimals. So they're almost 0, but not quite. Once we've created our distribution, we can answer questions C and D. Question C asks, calculate the probability that at least one of the 7 articles that you read contains no factual content. Let's think about the wording of this question. When they ask us about at least one of the 7 articles, what this means is 1 or higher. So what we can do is we can do a sum formula. We'll say probability of 1 or higher and say equals sum, and then select all of the probabilities that are connected to the numbers 1 or anything above 1, going from 1 and stopping at 7. Close the parentheses and press enter, and we'll have 0.578142. For problem D, they're asking about the probability that between 1 and 3 of the articles contains no factual content. So we'll make an entry that says probability of being between 1 and 3, and we'll do a sum formula where we select all the probabilities that are from 1 to 3, but we'll leave out the others. So we're going to draw our blue rectangle around the probabilities that are from 1 to 3. When we press enter, we get 0.573405. There's also a way to answer questions C and D without actually constructing the probability distribution. If we're going to try to find the probability that at least one of the articles has no factual content, let's begin by drawing a picture. Now, the lowest we could possibly have for non-factual articles is 0. It's always possible that none of them are non-factual. The highest we can go is 7. And if they want at least 1, they're looking for everything between 1 and 7. There's another form of the Binom-Dist formula called Binom-Dist Range. Now, when we use Binom-Dist Range, we enter the data in a different order than plain Binom-Dist. Our first entry is the number of trials. We'll call that N. Comma, and then we put the probability in the second slot. Now, since we're using Binom-Dist Range, let's now look at the range that we're going to use. We're going from 1 to 7. We'll call 1 our lower limit and 7 our upper limit. So next we enter our lower limit, and then we enter our upper limit. So again, Binom-Dist Range has 4 slots to place data in, but they're different than Binom-Dist. So when we do this problem, let's make a list of what we need. We'll have N, P, lower, and upper. Based on that, we can get our probability. Now, N was our number of trials. We type 7. P will be our probability of finding a non-factual article. That's 11.6%. Our lower for this question is 1, and our upper is 7. So to find our probability, we'll say equals binom.dist.range. For the trials, we'll click 7, comma, the probability, 11.6%, comma, the lower limit, 1, comma, the upper limit, 7. With all 4 of those pieces of data collected, we press enter, giving us the probability again of 0.578142. Now for problem D, we were asked to find the probability between 1 and 3. So again, we'll draw a picture. The lowest we could be is 0, and the highest we could be is 7, but we're only interested in 1 to 3. So this time, we'll enter 7 for our number of trials again, 11.6% for our probability. Our lower is still 1, and now our upper is 3. Again, we'll enter the Binom-Dist Range formula. We click the N first, the P second, the lower third, and the upper fourth. With all 4 cells in place, we press enter, and we get 0.573405 once again.